day, Matrix. This is a very exciting time. We are starting Matric, trig, and Matric equations. And in celebration, I think we should start with a song. Classic interpretation of Don Giovanni ate Masami. He loves salami. Okay, please feel free to sing along. Right, so trig equations, first of all. Let's have some basic recall. You should know this because we have revised trig equations. It's been in your tests, etc. But just in case your mind is feeling slightly weary, let's just remind ourselves. So the first way we can solve a trig equation is get a trig equation equal to a number. The other way is if I get a trig equation equal to the same trig equation. We'll look at those later. Okay. So if I had sine theta is equal to m, where m is a number between -1 and 1. Okay, remember, if sine theta was equal to 2, there'd be no solution because your y-coordinate cannot be bigger than your radius. Okay, so if you've got a sine theta is equal to some number between -1 and 1, then to find out, to solve for theta, to get the general solution, on your calculator, please don't ever write this down. Okay, on your calculator, say theta is equal to sine to the -1 of m. Okay, that'll give you the angle on your calculator. That says angle on your calculator. And then you're going to, because the period of a sine graph is 360, you're going to get another solution every 360 degrees because it's going to keep repeating itself. Or if you're thinking of the Cartesian plane, you'll be back at the same point every 360 degrees. So theta is going to be the angle on your screen plus k 360, or theta is going to be equal to 180 minus the angle on your calculator plus k 360. This is not k's. Okay, this is k is an element of integers. The way I remember, so for sine, it's the angle plus k 360, or 180 minus the angle plus k 360. The way I remember it is sine is positive in quadrant 2, just a way of remembering it. So it's the angle, or 180 minus the angle. This stuff, these basics, you need to know in your sleep without even thinking. So go try to do this. Solve for theta. Sine theta is equal to a half. So you could just, you don't have to use a calculator. You can think of your special angles diagram, or you can go shift sine to the -1 over half, and your calculator will spit out an angle of 30 degrees. I want you to split it straight away. Theta is equal to something, or theta is equal to something. So sine and cos, split it straight away. For tan, there's only going to be one general solution. So you get theta is equal to 30, and then it's going to repeat itself every 360 degrees. Or theta is going to be equal to 180. How do I remember it? Quadrant 2, sine is positive. 180 minus 30 plus k 360. K is an integer. Okay, so your solution set is 30 plus k 360, or theta is equal to 150 plus k 360. Voila, it is done. Okie dokie. Right, the next one is cos, and if you've got solving a trig equation, you've got to solve for theta, and you've got cos theta is equal to m. Okay, for all of these questions that solve for theta, we're finding the angles that satisfy the equation. Okay, again, if cos theta is equal to m, to have a solution, m must lie between -1 and 1. You can think about it on the Cartesian plane, or you can think about it on the trig graph of cos. And for cos and for sine, if you think of the range, in other words, all the possible y-coordinates, so you can think of those as being your y-coordinates. Your y-coordinates have to lie between -1 and 1. It's got to do with the range of the graph. Okay, that restriction they often test in sneaky little questions in section B. Okay, so if you're solving a trig equation like that on your calculator, whatever that number is, you'll go cos to the -1 of that number, and that'll give you an angle on your calculator, and you're going to get an answer every 360 degrees. Okay, because it repeats itself every 360 degrees. The period of the graph is 360 degrees for cos, standard cos graph. Or you're going to get negative, the angle should be over there. If that's positive, the angle, that'll be negative the angle, plus k 360. Okay, I'll always write them separately. I just get into that habit because there's some cases where if you don't do it separately, if you just write plus minus, it can become a mess. Okay, a way you can remember it, okay, is that for cos, where's cos positive? Here in quadrant 1 and in quadrant 4. So in quadrant 1, quadrant 4, it's the angle or negative angle. It's just a way of remembering it. A lot of you have a heart attack and you say, but what about obtuse angles? Well, obtuse angles, the ratio for cos will still be the same because cos is x over r, so there it would be negative a and there it would negative ba, and radius would be the same. If you don't quite get that explanation, it's not the end of the world, just for those of you that are worried about that. How much fun are you having? Okay, and your last type of equation, if you've got tan theta is equal to some number, okay, now for tan, okay, what could those numbers be? Well, you could have the number 1,000,000. Why? Okay, you could have any real number, because if tan theta, what's the range of a tan graph? Okay, it goes up to infinity and it goes down to negative infinity. So for sine and cos, those numbers are stuck between -1 and 1. Okay, you always get solutions only in that interval, where for tan, because of the range goes up forever and down forever, okay, to infinity and to negative infinity, m can be an element of real numbers. And then you'll simply go shift tan to the -1, don't write that down, just write down the angle on your calculator, plus k180. Okay, why plus k180? Good, because the period of a tan graph, period of a sine graph and a cos graph is 360, so that's why you get a solution every 360. Here you're going to get a solution every 180. So if that's the solution, then in 180 degrees time you're going to get a solution. Every 180 you're going to get a solution. If you want to think of it like this, if here's your solution, where's tan positive in quadrant 1 and quadrant 3, okay, if there's a solution, there will be a solution every 180 degrees, you're going to get a solution. So that's where the plus k180 comes from. So let's quickly do this one. Solve for theta, okay, and if we said tan theta is equal to 1, well, you should be able to do this without a calculator, because what's it saying? It's saying the y coordinates and the x coordinates are the same. So you could be thinking of it as looking over here, so we could have 1, 1, we could have 2, 2, whatever, okay? So we're on this line where y is equal to x, so that's 45 degrees. Okay, so you're going to have a solution at 45 degrees, and then every 180 thereafter. So because if 1, 1 was a point, -1 minus 1 would be a point as well, etc. So theta is equal to 45 plus k180, and you have to specify that k is an integer. Just in terms of this graph, the question is saying when is the y, tan theta is equal to 1, they're saying when is the y coordinate equal to 1 on the tan graph? Well, when x is 1, y is 45, so 45 happens, okay, sorry, 45, 1, so y is equal to 1 at 45, okay, and then every 180 degrees thereafter. So at 45, 225, tan of 225 would also be equal to 1, 45 minus 180 minus 135, tan of minus 135 would also be equal to 1. Tan, the y coordinate is 1 at 45, and then every 180 degrees thereafter. Right, so that's the end of our lovely introduction. Yeah, Bob. So we're going to do now exercise 4.8, page 179, and I'm going to go over A1, 3, 5, 7, and 9, and B. Okay. And the question is determine the general solution, in other words, solve for theta for all of question A. Right. So let's start with Tandy. Okay. So guys, your objective is you want to get a trig function equal to a number at this stage of your life. Okay. Because then we can do something with it. We can solve. And that's often going to be your hardest step, not what we just did. The hard step is to get to this point over here. So you've got to look for patterns. And finally, this should look familiar. Go to your formula sheet, look for this pattern. Where do you see cos A, cos B, plus sin A, sin B? Find that on your formula sheet, and you'll see that is equal to what? Indeed it is. Cos, opposite for cos, A minus B. Right. So you're going to use that to simplify that. Okay. Right, off you go and try that. So it's going to become what? It's going to become cos 4 theta minus 40 degrees. Okay. That's just, that whole thing over there, using this logic, has become cos 4 theta minus 40 degrees, and that is equal to -1. Okay, so we're just going to use our calculators. There's an easier way to do it, but I think I might confuse some of you by doing it initially. Okay, so if you've got cos 4 theta minus 40 is equal to -1. Okay, to solve a cos equation, what do we do? Shift cos to the -1 of -1, and we get an answer of, okay, 180 degrees, -180 degrees on your screen, or 180 degrees. So you're going to go 4 theta minus 40 degrees is equal to 180 degrees. plus k360. Do your split straight away. Okay. Or 4 theta minus 40. So with cos, remember we're using this logic. We've got cos theta is equal to m. What do we say? Theta is equal to the angle plus k360, or theta is equal to negative the angle plus k360. So you're going to have 4 theta is equal to 180 plus k360, or 4 theta minus 40 is equal to negative 180 plus k360, where k belongs to the set of integers. Okay, k is an element of integers. Right. So now you solve each of those separately, and you're going to get 4 theta is equal to 220 plus k360. Okay, and let's divide by 4, and you're going to get theta is equal to 55 degrees plus k90. I divided everything by 4, and over here, or you're going to get, to split it up into two sides, 4 theta is equal to minus 180 plus 40, which is minus 140 plus k360. Okay, divide everything by 4, and you get theta is equal to negative 35 plus k90. So your solution is 55 plus k90, or negative 35 plus k90. Well done, Tandy. Good day. Right, Sasha, number 3, 4.8, go for it. Okay, so Sasha's having a good look at this, and she's thinking, so easy. I'm going to simply change tan theta to sin theta cos theta. What kind of idiot do you think I am? I say, well done. And then she says, well, I'm a little bit stuck here, but we always have this option. Let's make tan theta sin theta over cos theta. And we're going to have 2 sin theta cos theta. Right, and then she says, well, fractions suck. So let's get rid of the cos theta. How are you going to do that? Oh, yes, indeed. So actually you're going to times both sides by cos theta, and you end up with sin theta is equal to times everything by cos theta, and you get 2 times that side, it disappears, times this side by cos theta, and you get that. And now the huge temptation is to divide by sin theta. And what will happen if you do that? Sin theta is a variable. Okay, you can't divide by a variable. Why not? Because you'll lose a solution. Divide by constants, but you can't divide by a variable, you'll lose a solution. So you may not divide by sin theta, and so now we're going to get everything to one side of the equation, and we're going to have 0. You guys are obsessed with getting 0 on the right, but there's no reason that you have to. So you're going to have 0 is equal to 2 sin theta cos squared theta, okay, minus sin theta. So you've got some kind of a quadratic here, so you want to end up with a times b is equal to 0, because then a will be 0 or b is equal to 0. So in other words, you've got to factorize that. So what's your common factor, Sasha? Yes, your common factor is sin theta. So you get 0 is equal to, take out sin theta as a common factor. What I have to times by to get back to here? 2 cos squared theta minus 1. Okay. So 2 things times together, that's a 0. 2 things times together give you 0. A times b is equal to 0. The one must be 0, the other must be 0. Same logic holds here. So sin theta is equal to 0, or 2 cos squared theta minus 1 is equal to 0. Now, okay, you could, okay, let's do this slide first. You could go get cos theta on its own. In other words, well, cos squared theta is equal to half, so cos is equal to plus minus 1 over root 2, and you get, okay, and you could do it like that, it'd be perfectly correct. But, okay, Sasha has just told me that, but hang on, 2 cos squared theta minus 1 is the same thing as cos 2 theta. Okay, and it is. Okay, so that's just something, okay, that a lot of you may have missed, but it can save you a bit of time. As I said, you could have done it the other way, you get the same answer. So you get cos 2 theta is equal to 0, because cos 2 theta is 2 cos squared theta minus 1. Go check on your formula sheet. And how do you solve a cos equation? You go shift cos to the negative 1 of naught. Okay, and if you go shift cos to the negative 1 of naught, you're going to get 2 theta, where is cos equal to naught at 90 degrees. So I get 2 theta is equal to 90 degrees plus k 360, where k belongs to the set of integers, but there are always 2 solutions. Okay, so or you're going to get, are we going to fit this in? It's quite challenging. Okay, so or we're going to have 2 theta is equal to negative 90 plus k 360. Okay, and if you divide both by 2, you get therefore theta, if I divide this one by 2, theta is 45 degrees plus k 180. Okay, or theta is equal to negative 45 plus k 180. So that's that side of the equation over there. Okay, 45 plus k 180, or negative 45 plus k 180. Hope that makes sense. Okay, and on the other side of the equation, so I'd solve this one over here. Okay, and on that side of the equation, when is sine equal to naught, if you use your calculator, you're going to get, when is sine equal to naught at 0 degrees, so you're going to get theta is equal to 0 degrees plus k 360. Always 2 solutions for sine and cos, or theta is going to be equal to 180 minus 0 degrees plus k 360. Okay, we could simply write that as theta is equal to k 360, or theta is equal to 180 plus k 360. By the way, you could write those as just theta is equal to k 180, but don't worry about that. Okay, Sasha, I'm so proud of you. Okay, can you see all of that? Or let's do it over here. Theta is equal to 0 plus k 360, or theta is equal to 180 minus 0 for sine, so that's 180 plus k 360. So there's your solutions. 0 plus k 360, 180 plus k 180 degrees plus k 360, 45 plus k 180, and negative 45 plus k 180. That's the general equation for that over there. Remember, don't divide by a variable. Well done, Sasha. Ciao. So, back in our Panama hat, and in honor of the smartness, because I do know she likes boys from posh schools, Maxine, otherwise known as Maximilian Glick, and Tombi, otherwise known as Hippie Tombi, will be doing this sum for us. So, gird your loins and let's get going. Right. So, you look at that, and Maxine, what do you think? Oh, yes, indeed. Sine 2 theta, everything else is theta. There's a double angle, so let's get rid of that naughty, naughty person. So we go 3 sine squared theta plus 2 times 2 sine theta cos theta. I've changed sine 2 theta into 2 sine theta cos theta plus cos squared theta is equal to 0. Okay, you can obviously go straight to this line. 3 sine squared theta plus 4 sine theta cos theta plus cos squared theta is equal to 0. Right. So now you look at that and you think, oh my goodness, okay, what am I going to do? Okay, Ipitombi says, well, so I don't know really what's going on, but I know that if I go to the side of your page and you replace every sine theta with, let's say, x, and every cos theta with y, then the pattern will be 3x squared plus 4xy, okay, plus y squared. And it's a quadratic, and in order to solve it, we want to factorize that. Can that be factorized? Yes, indeed it can, Epitombi, because you're going to have 3x and an x. Okay, and you're going to have a y and a y. And all the signs are plus. Okay, and if you times that back out, you'll get 3x squared plus 3xy plus xy is plus 4xy plus y squared. Well done, if you told me. And that helps us how? Well, now using that logic, I can factorize that. X was sine, so I'm going to have, remember, do that on the side of your page. So you're going to have 3x, with, in other words, 3 sine theta. Some of you will be able to do this without going through that process. That's fine. 3 sine theta plus cos theta, because it's 3x plus y, times x plus y, in other words, times sine theta plus cos theta equal to 0. And I've got the scenario I want now because I've got a times b is equal to 0, so one of them must be equal to 0. Oh, we are doing so well here. So, two things times together give you 0. What does that mean? Indeed, it means 3 sine theta plus cos theta is equal to 0. Two things times together give you 0. That one must be 0, or this one must be 0. So, or sine theta plus cos theta is equal to 0. So now you've got to solve both of these separately. So Maximilian, what are you going to do? Yes, indeed. So I get 3 sine theta is equal to negative cos theta. And then, oh, yes, indeed. Okay, you divide both sides by cos theta when you've got, because the angles are the same size and you've got a single term on both sides of the equation. So then you're going to end up with 3 tan theta is equal to negative 1. So tan theta is equal to negative a third, right? Okay, remember, if you've got sine and cos, okay, a single term on both sides of the equation, the angles have to be the same. Divide both sides by cos, and we can get a nice simple tan equation. And when you calculate it now, if you go shift tan to the negative 1 of negative a third, you get negative 18,43 plus k 180, somewhere we should write k belongs to the set of integers. Okay, so well done, Maximilian. Right, and Ibitombe, let's do this one. And I'm going to get sine theta is equal to negative cos theta. So you get excited because it's a single term with sine and cos. So you divide both sides by cos. And you get tan theta is equal to negative 1. Go check on your calculator or use your head. You'll get theta is equal to negative 45 plus k 180. I'm so proud of you, Maximilian and Ibitombe. Congratulations. Okay, so we're going to have practicing wearing masks. Notice how one's ears become little but wide, and celebration of masks because their parents are phenomenal advocates of masks. We're going to have Valeria and Alero doing the sum. And it's quite an evil sum, okay, and you've got to solve for theta. So the hard part is the beginning part. And so Valerie, yes, you're quite right, just pick that up. 1 plus 2 sine theta cos theta minus 4 cos squared theta is equal to 0. Right, now, yeah, you're a bit screwed. Because what you want, in the earlier notes, I said that if you have sine theta cos theta, okay, and you've got a 1 here and a sine squared, you can really only factorize this if there's a cos squared and a sine squared. Because if you've got xy, if you think of it like this, plus y squared, you need an x squared as well, if that makes sense. Something x squared in order to factorize it. Okay. So in this scenario, when you've got sine theta and cos theta, and a cos squared or a sine squared theta there, and a 1 there, this is about the only scenario where we're going to let 1 be equal to sine squared theta plus cos squared theta. Okay. Normally it's the other way around. We make sine squared theta plus cos squared theta is equal to 1. But in this scenario, where sine and cos are glued together, and cos squared is there, okay, to get a sine squared there, we're going to change that 1 into that. That's about the only time we really do that. Please don't do that often unless it's the last resort. So then this sum is going to become sine squared theta plus cos squared theta, that's the 1 over there, okay, plus 2 sine theta cos theta minus 4 cos squared theta, okay, is equal to 0. Right, so add like terms, and we're going to have sine squared theta plus 2 sine theta cos theta, okay, and then cos squared theta minus 4 cos squared theta is negative 3 cos squared theta. Yes, okay, is equal to 0. Right, now that can be factorized. So look for the pattern. So that's right, Illyria, go to the side of your page, and you've got x squared plus 2xy minus 3y squared. Okay, so that hopefully can be factorized. Well, you're going to have an x, you're going to have an x, you're going to have y, you're going to have y. One's going to be plus, one's going to be minus. You want to end up with plus 2, so that's going to be plus 3, and that's going to be negative y. Always check x squared plus 3xy minus xy is plus 2xy minus 3y squared. So this is going to be the pattern of your answer. Okay, so sine we let be equal to x, so it's going to be sine theta minus cos theta. These are quite tough, guys. Sine theta minus cos theta, okay, and sine theta plus 3 cos theta is equal to 0. So if you're feeling insecure, Valerie times it back out. You get sine squared theta plus 3 sine theta cos theta minus sine theta cos theta is 2 sine theta cos theta minus 3 cos squared theta. Right, so if you've got a times b is equal to 0, a is equal to 0, or b is equal to 0, that's the logic we're using now. Okay, so therefore, two things times together give you 0. So sine theta minus cos theta is equal to 0, or sine theta plus 3 cos theta is equal to 0. Now you're going to solve both of those separately. So, Alero, what you're going to do, yes, the angles are the same. So get sine on one side, cos on the other. What do we divide both sides by? Divide both sides by cos. And you get tan theta is equal to 1. So tan theta is equal to 1. So what's theta? Use your calculator. It's 45 degrees, or you should know that one actually, plus k 180, where k is an integer. So there's your one solution set. And here, Valerie, Alero, we're going to have sine theta is equal to negative 3 cos theta. What I do now, all the angles are the same, that's the most important thing. So divide both sides by cos theta, and I end up with tan theta is equal to negative 3. So get your little calculator out and go shift tan to the negative 1 of negative 3, and it gives you negative 71,57. So theta is equal to negative 71,57 degrees plus k 180. We are getting there. Whew, 7 is done. Okay, this is page 7, I think. Right. 7 on page 7. I think that happened last time as well. Isn't this amazing? How's it, my butt? Right. Last time, so we'll have some classy people do this. People from my hood, from Bedfordview. Right, so let's have Bianca and Tatiana going to do this one. And the question is, solve for theta. 4 sine theta cos theta is equal to 1. Well, your hint is this. Okay. Sine 2 theta is equal to what, Bianca? Yes, 2 sine theta cos theta. Right. So now, if we work the opposite way, we know that 2 sine theta cos theta is the same thing as sine 2 theta. But 4 sine theta cos theta, we can write as 2 times 2, because 2 times 2 is just 4 sine theta cos theta. And then what are you going to do, Tatiana? Yes, indeed. Okay, you're going to replace 2 sine theta cos theta with sine 2 theta. Okay, 2 sine theta cos theta is sine 2 theta. So you've got 2 sine 2 theta is equal to 1. Divide both sides by 2. And we've got sine 2 theta is equal to a half. And now life is good. You're going to get two solutions for sine. It's going to be the angle on your screen, or 180 minus the angle on your screen. So you're going to get the angle we're solving for is 2 theta in this case. And sine to negative 1 over half is what, Bianca? Yes, it's 30 degrees. Plus k 360, where k is an integer. Let's just scribble that here somewhere. K is an integer. Okay. Always split it immediately, or 2 theta is going to be equal to what, Tatiana? That's right, 180 minus the angle on your screen, plus k 360. So here, solve both sides separately. Here you're going to get theta is 15 degrees plus k 180. And here you're going to get 2 theta is equal to 150 degrees plus k 360. So theta is equal to 75 degrees plus k 180. Girls from the east, well done, phenomenal stuff. Right, you've done A 1, 3, 5, 7, 9 of that exercise. Go to the even numbers. So in other words, A 2, 4, 6, 8, and 10. Okay. Thanks, guys. May the force be with you.